Okie ding dong. Pause and copy, pause and copy, pause and copy. So this is not in the book, not in the book, not in the book. So we have a very important and useful test, the ratio test. So you calculate this funny thing, and then you classify. One of these three things is going to happen. Hopefully not the third, because the third means unhappy face. I have no information. Okay, pause and copy these examples, which I will go through one by one. Number one. So remember, L is limit absolute value and plus 1 over n. And that is, so here's an. An is equal to n 1/2 n. An plus 1 is, I take this expression here, and for this n and this n, I replace them with n plus 1. So n plus 1, 1/2 n plus 1. So the n's circled in red got replaced with n plus 1s. That's it, that's all. So when I do this big honking fraction down here, it gets a bit messy. So this is going to test your algebra skills a little bit. I want to simplify. So looking at these two, I just cancel my n's. And with the remaining fraction, and choose to put it on its own. Okay, what you can do here is you can, with an absolute value, you can move numbers out. If they happen to be negative, then when they come out, you make them positive. And and even n over n plus 1 over n is actually positive as well, so we don't need to worry about that. Okay, now I see that I have created or committed a mortal sin. I dropped my limb. As some of you know, I take marks off of that for that. But it's very easy to fix. I will allow you just to throw an L in here, throw an L there, throw an L there, throw an L wherever. Just throw an L in there just to indicate to me that you recognize your mistake. Okay, limit. We're still doing limit as n goes to infinity of this item here, and that is just 1. Okay, why is that limit 1? Well, think about it. This is 1,000,000 plus 1 divided by 1,000,000. Okay, it's getting very close to 1 now, isn't it? So we have 1/2 times 1, so we get 1/2. So our L is 1/2. And how does that compare to 1? Well, it's less than 1, less than 1. So we look at our ratio test and we say if L is less than 1, then we have convergence. So therefore, summation n 1/2 n is convergent, and then we should say by ratio test. I'm going to skip number 2 for now and jump to the more interesting number 3, which I've forgotten. What is number 3? Starting at 5. I think I got that right. Let me double check. Oh, forgot my N there. All right. Got a factorial to deal with. This 5 is a red herring. It does not matter for ratio test. It does not play a role. So my AN is, well, let me just do this in red. Here is AN. So AN plus 1 is -1 plus 1 to just the N now. Then 3 N plus 1. Be careful with this one. Maybe use square brackets. Okay, look what happened here. This N got replaced with N plus 1. Okay, so the 3, is going to multiply the N and also the 1. Be careful with that. Okay, where was I? L is limit of N plus 1 all over AN, which is limit of this awful thing. Give yourself lots of space here. Let's write this as 3n plus 3. Divided by, okay, I want you to make sure that this line here is longer than this line here. Okay, now we have absolute value. What does absolute value do to these thingamabobs? Well, it suppresses them, it kills them, right? So just ignore them, just drop them without even thinking. No thinking allowed. And what's left? I have a fraction divided by a fraction. So I should flip and multiply. So I flip the bottom fraction. Like so. And then I would group my, not terms, but like factors. Group my like factors. I can draw my absolute value at this point because this expression is positive. So I can draw my absolute value once the negatives are dealt with. Where was I? 3 n factorial all over 3n plus 3 factorial. Let's take that factorial bit aside. How do I want to say this? Well, I showed you how to do this in the sequence part of the course. Let me do it a little bit differently here. Okay, on the bottom, what do I get? I get the multiplication of the numbers from 1 all the way to n plus 3. So this part brings me up to 3n, and then I have to go 3 factors further. Okay, now I've done that, I can see the cancellation. And that's what survives. Okay, back to blue. Here, I got the same base. So I should subtract the exponents, giving me 2 to the power of 1. So just 2 there. Times 1 over this thing in green over here. Okay, now I can just look at this fraction, or 2 times a fraction, and say as n goes to infinity, the denominator wins. So I get 0. And that's less than 1. Therefore, my original series, n is equal to 5 to infinity. Totally forgotten what this series is. I'm going to guess -1 to something, 2 n minus 1, 3 n factorial. How's that? Did I write that -1 to the n? Oh, ho, ho, ho. Throw my hand there. Okay, therefore, this series is convergent by ratio test. Two, exercise. I want you to try this. And I believe I gave you the answer above. Four. What is 4 again? Do. 4. Trick question 4. 1 minus n squared over n squared plus 1. It's a trick question. Not too tricky. If I write down an, I think when you're doing any series testing question, you should always check to see what the limit of an is. If you don't get 0, then you are a happy camper, because you are done. So in this case, I'm going to get a limit of -1 ultimately. So just -1. Now remember, test for divergence. If lim an is not 0, then the series is divergent. So this is not 0. Therefore, series, this one, is divergent by test for divergence. Okay, I'll say it again. If you are testing any series to see if it's convergent or divergent, you should always, at least mentally, check this limit. If you don't get 0, then you're done.